just to go over the galactic time periods again, 0 to 1 seconds, we had the age of heat and radiation. And basically what we have the mother universe, and in that universe, there was a black hole that was formed. And basically, in that black hole was a singularity. And that singularity caused a rip in time and space. And because of spaghettification, or the effects of spaghettification, atoms start to break apart. And they released huge amounts of energy, c². But as they fall towards the singularity, they broke into the simplest components, which some people surmise as little strings. So at the center of a black hole, basically, instead of huge amounts of light and radiation and heat, I would suggest that it is freezing cold, in fact, close to 0 degrees Kelvin. Now you have that split in time and space, and basically all that energy poured out into the newly created universe. And in that first second, you can imagine that the heat and radiation, now you have these very tiny strings so close together, and they are bonding like nobody's business. And basically you went from dark energy to dark matter to matter pretty well within a billionth and a billionth of a second. Now you can imagine that there is huge amounts of heat, like maybe 1 billion degrees Celsius. And in that time, helium was formed by the fusion of hydrogen. The other thing too is that this split in time caused a huge amount of energy to be poured into the newly formed universe. And what happened is that the energy uniformly was distributed in every direction. That's why the universe is pretty well homogeneous, meaning it doesn't matter where you look, in whatever direction, basically it's the same amount of matter spread through the universe. The other concept I introduced was inflation. And basically, the universe went from a singularity to a size of a basketball within a billionth of a second. What that meant was that the universe expanded faster than the speed of light. That seems to break Einstein's rule that nothing travels faster than the speed of light. Now, I don't think it actually does break that rule, because nothing travels faster than the speed of light through space. It doesn't mean that space cannot expand faster than the speed of light. So, in the early universe, it expanded. The universe just expanded at a huge, great, accelerated rate. And then all of a sudden, just stopped. Doesn't mean it didn't expand, just meant that it expanded a lot slower than the first. Now you can imagine that you have a water balloon and you have this gigantic hose. That balloon is going to expand as fast as the pressure of that hose. And that's basically what happened at the very, very first seconds of the creation of the universe. Now, the age of matter. So, in the first part of the universe, first early stages of the universe was relatively small. And basically, the strings of energy that's being poured into the center of that universe are so close together that they were able to interact with each other. Don't forget that the universe at that time was extremely dense. So matter is able to bond with each other, or at least the strings were able to bond to each other to form dark matter and very quickly matter. Now, during this time period, matter was the predominant source of energy. Remember, E equals mc squared. And basically what Einstein said, that was energy and matter are interchangeable. And the form of energy at this particular time was just pure matter. So you still had energy pouring through the singularity. And that would cause the expansion of the universe. But the matter in the universe is also, the gravity is also holding that expansion back. So the expansion is much slower than what it is today. Now fast forward 1 billion to 10 billion years. Now the universe is expanding again because the energy is still being poured right dead center. So now the universe is much larger, much cooler, and the strings are further apart. But still, the strings are able to kind of bond to each other. Now, dark matter is now the predominant energy, source of energy, right? It's outstripping visible matter. And the thing with dark matter is that it's not it's not affected by radiation. So dark matter is able to kind of get together through gravity, forming the dark web. And at the joins, there is a source of gravity there that attracts matter. And that's where the planets and the solar systems and the galaxies start to form. And what's happening is that the low density areas are being eaten up by, attracted to the high areas of density. So this is where galaxies, planets, stars are starting to form. Now we fast forward 10 billion years to the present. The universe is now huge. Now, dark energy is still pouring into the universe, causing it to expand. But the difference is that the dark matter and matter are so diluted now that their gravitational effects on the expansion of the universe is also diluted. Now, dark energy is now taking over relative to dark matter and visible matter. What that means is that the expansion of the universe is now accelerating.